Hello friends, today we are going to learn about kinetic and potential energy. We are actually going to simulate the effects of mass, friction and gravity. We are going to consider an ideal case of frictionless system and see what happens. Meanwhile, we will also be looking at how the total energy is equal to potential plus kinetic using simulation, and also how the dissipation of the friction takes place in form of heat. So this all we are going to look in a simulated form. So let's go to that simulation and see what it is about. So let's take a look on how the simulation will look like. So on right bar you see this mass tab. So I am putting this mass of the person who is skating on a track which looks like a parabola to around 40 kgs. So currently gravity I am putting at normal, and since I said that we will be simulating a frictionless scenario first, which is the ideal case, I am putting friction to 0 currently. And on my left hand side you can see these are the different energies. So this is total energy. So you can see the total energy is equal to potential energy right now. The thermal energy is 0, and of course kinetic energy is 0 since the person is not moving. Now let me start the simulation and see what happens. So you can see since it is frictionless, the person will keep on moving in this path without stopping for infinity because there is no friction. Now let me just increase the weight. So here it was 40. So you can see as I am increasing the weight on my left hand side, the total energy is also increasing. The reason is potential energy is nothing but m into g. Since I am increasing the mass of this person, the total energy is also increasing. Now if I start the simulation again, the same thing will happen. Now let's see what happens with if I increase the gravity. See, if I increase the gravity, that means I am increasing the acceleration due to gravity. So m into g is again increasing, so my total energy is increasing at this point, which is equal to potential energy at this point. So when I start the simulation, you can see, okay, now let's do one thing. We keep gravity at normal. Let's give some friction. So I am increasing the friction to some extent now, and let's see what happens. So as you can see, uh, the amplitude of the skate path is decreasing and the energy is getting dissipated in the form of thermal. So thermal energy is increasing. So the person will stop when thermal energy dissipated will become equal to total energy. The reason for this is since I have given some friction on this track, so friction is creating, or it is helping to create the heat energy which is getting converted. So this heat is basically the initial potential energy which we saw here. So here there is no thermal. Now you can see as the time passes the thermal energy increases and these bars they reduce in height. Now let's see what happens if I reduce the weight of person, if I reduce the gravity but I still give friction. Let me just go ahead. You can see the velocity is less on speed, but the same phenomena happens. Since gravity is reduced, my total energy is decreased, but in the end the person is going to stop because the friction is dissipating the energy in the form of heat, and that's how this kinetic energy and potential energy principle works. So that's how we saw the concept of potential and kinetic energy. We saw what happens when friction is zero. We saw the effects of mass and gravity and their interconversions of how the thermal energy is getting dissipated, how the total energy is getting converted into kinetic and potential. Thank you.